the lesson matter around us. Today we again discuss the previous lecture. What is solid, what is liquid, what is gas, the properties of solids, liquids and gases, the concept of compressibility, diffusion discussed in previous classes. Children, can matter change its states? Yes. Can matter change its states? Children, can matter change its states? First one, solid to liquid. Second one, liquid to gas. Third one, gas to liquid. Fourth one, solid to gas. Solid to gas. Example of solid to liquid. First one, ice to water. Second one, liquid to gas. Example of liquid to gas. Evaporation of water. Third one, gas to liquid. Example of gas to liquid. Condensation of water. For example, fourth one, solid to gas. Do you see the children? Do you see the board? Observe the solid change. Can matter change its states? Example of solid to gas. Camper diffusion directly to gas. Are you understand, children? Children, how solid convert into liquid? Ice in solid state can convert it into water. Second one, liquid to gas. Example of evaporation of water. How to turn into gas? The evaporation of water in 100° centigrade. Petrol, alcohol evaporating in low temperature. Third one, gas to liquid. Children, how gas turned into liquid? Condensation of water. For example, dew, fog, etc. Fourth one, solid to gas. For example, camphor diffusing directly to gas. What is matter made up of? previous classes, what we found that three states of matter: solids, liquids, gases, made of very tiny particles. All matter is made up of very tiny particles. Sometimes closer to each other, sometimes far away. Children, do you see the board? Children, how small are the particles of matter? Children, do you see the board? Observe the diagram. Children, are you okay? Children, do you see the activity? Children, Children, take a beaker with water. Add 1 or 2 crystals of potassium permanganate and dissolve them in water. Children, what color do you observe? Children, do you observe pink in color? Children, are you understand? Children, now take out approximately 10 ml of this solution and added into 90 ml of clean water. 90 ml of clean water in another beaker. Now take out approximately 10 ml of this solution, added into 90 ml of clean water in another beaker. Children, what does happen to color of water in second beaker? Light in pink color. Children, do you observe the activity? Children, again take out 10 ml of this solution. And added into the another 90 ml of clean water. Carry out this process in 4 or 5 times. Children, observe the activity. Again, take out 10 ml of this solution and add it to another 90 ml of clean water. Children, again take out 10 ml of this solution and add it to 90 ml of clean water. Children, finally, that we observe the change in intensity of color of the solution. What do you understand from this activity? Children, repeat this activity by taking a few crystals of copper sulfate instead of potassium permanganate. After doing this activity, several interesting conclusions can be drawn. We concluded that these must be several tiny particles in just one crystal of potassium permanganate, which are uniformly distributed in water to change in color. Few crystals of copper sulfate to has several tiny particles which are distributed in large quantity of water to give color. So both solids, potassium permanganate and copper sulfate crystals, including water, made up of tiny particles. So both solids or liquids made of tiny particles. Children, how do the particles of the solids distribute in the liquid? Let us find. Children, there exists space between particles. Take a graduate beaker and fill it with some water and mark the water level. Add some salt in water and mix it well. Observe is there is any change in water level. If we add some more salt and stir it again, what we observe? Does the level of water change? Where did the salt go? Liquid particles in a liquid have some space between them. Solid particles enter into the space between the liquid particles are dissolving solid in liquid. Observing the force of attraction between the particles of matter. Open a water tap and allow the water to reach the ground. Now try to break the stream of water with your finger. Can you break the stream permanently or momentarily? Are you able to break the stream of water any change? Where from the tap to ground? What is the reason behind the stream of water remaining together? Now try to break a piece of iron nail with a hammer. Are you able to do it? If yes, does it rejoin? From above observations, we can say that particles of matter have forces acting between them that keeps the particles together. It is also clear that this force is not equally on different forms of matter. Children, how diffusion take place? Diffusion can be possible only when the particles of matter move continuously. In the intrinsic activity, the particles responsible for scent move and enter the space between the air particles. The scent particles quickly spread across the room. The particles of solids, liquids, and gases can diffuse into liquids and gases. Rate of diffusion of gases is higher than the liquids, while the rate of diffusion of liquids is higher than solid. Children, do you observe? Similarly, the greater diffusion rate in liquids compared to solids is because particles in liquids move freely and have greater space between them when compared to particle of solids. Children, look at the picture. See the difference among solids, liquids, and gases. In a gas, the particles are not as close together as in a liquid. If a colored gas is mixed with a colorless gas, the color spreads evenly in it. This happens faster in gas than in a liquid because of large gap between the particles of gas. Few particles of gas obstruct in the way of spreading. See the bromine when it diffuses through air. It is a brownish gas. Hence, its diffusion in colorless air can be seen clearly. If we allow bromine to diffuse in vacuum, it diffuses faster into vacuum because there are no particles to obstruct in its way. How does this change of state take place? Effect of temperature. What happens if water is heated during the diffusion of liquids? How does this experience help you to discuss about the effect of temperature on change of states in matter? Let us find effect of temperature on change of state. Take a beaker and added 100 grams of ice cubes. Keep the bulb of laboratory thermometer in contact with the ice cubes. Note the temperature. Heat the beaker slowly. Record the change in temperature for every 30 seconds by stirring the ice cubes continuously using a glass rod. Ice melt completely. Does the temperature change continuously? At what temperature does this happen? Did you notice the changes in temperature at various stages? Like just start melting, during melting, and at completion of melting. Melting point of ice is 0 degree Celsius. The temperature of mixture of solids, ice and liquid. Water does not change. It remains constant. At a certain temperature, the solid melt into liquid. A specific temperature at which a solid and liquid are in equilibrium is called melting point. Children, once again, a specific temperature at which a solid and liquid are in a equilibrium is called melting point. The process of changing solid to liquid is known as fusion or melting. Above activity, the heat energy absorbed by ice without showing any rise in temperature is used up in changing the state by overcoming the forces of attraction among the particles. Particles in water at 0 degree Celsius have more energy as compared to particles in ice at the same temperature. What will happen if heating of water continues? Boiling point of water is 100 degrees Celsius. Particles in water vapor have absorbed additional energy in the form of latent heat of vaporization. Now we have learned that substances around us change states from solid to liquid. Finally, we found that melting boiling point. Effect of change of pressure. We already know that various kinds of states are due to the difference in the distance between the consistent particles. Due to think that increase or decreasing the pressure can change the state of matter. Solid carbon dioxide converts directly into gaseous state when the pressure is decreased to 1 atmosphere. Due to this reason, solid carbon dioxide is also known as dry ice. Thus, we can say that pressure and temperature determine the state of a substances, whether in it will be solid, liquid, or gas. Evaporation. Do we also need to supply heat or change the pressure for changing the states of matter? Can the change of states from liquid to vapor take place without the liquids reaching its boiling point? The particles of matter, irrespective of the state at the given temperature, possess different energies. In liquids, the particles at the surface possess higher energy than particles in the blue of water. This phenomena of change of a liquid into vapor at any temperature below its boiling point is called evaporation. Take a small amount of spirit in a cup. Pour a few drops on your palm. Observe the changes. Once again, take a few drops of spirit and pour the drops into petri dishes individually. Generally, the petri dishes are shallow glass or plastic cylindrically lidded dishes used in the laboratory. Place both dishes under ceiling ceiling fan and switch on it. Close the lid one dish. After 3 minutes, check the quantity of spirit in both the dishes. In this activity, we observe the spirit disappear in the dishes kept under the ceiling fan. At the same time, some quantity of spirit can be found in the dish which is closed. Finally, we learn that evaporation is a surface phenomena. During evaporation process, the particles escape the surface of liquid. The decrease in the surface area provides more scope for particles to escape from the surface, and this increases the rate of evaporation. Humidity is another factor that affects evaporation. The amount of water vapor present in air is called humidity. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water vapor in high in air, the rate of evaporation will decrease. So, clothes dry slowly during rainy season.
Experience with evaporation. Observe cool after sweating children's. If you done physical exercises, the sweat evaporates from surface of your body by observing the heat from your body. This make you feel cool. Friends, can you guess some more examples? Effect of evaporation. Children, write the homework. Explain diffusion of matter. Once again, first one, explain diffusion of matter. Second one, write the properties of solid, liquid, and gases. Children, once again, write the properties of solid, liquid, and gases.